The focus of this discussion session is on how radionuclide metrology could impact mass spectrometry. Maybe first I will shortly introduce myself. I'm a radiochemist at LNHB, which is LNHB is a lab of CEA, the French Atomic Energy Commission. Yeah, at LNHB, as we said earlier, we do not have mass specs. We are for this. We are collaborating with another lab, or other labs from CA, such as mainly CA Lani in Saclay. And at LNHB, I'm responsible for source preparation, and I'm also very involved in providing materials for proficiency tests at the French level. So there's kind of a link with the reference material we'll be speaking about. So we chose to, we chose to focus on reference materials, possibly also on spikes. So here, I'm not really aware of what Ben would have liked to raise during this discussion sessions. We didn't discuss much about this. So feel free also to add some subjects. So the main uses of CRMs or RMs, in fact, they are quite wide because they can be used for several purposes, especially the calibration of a measurement system, possibly for traceability, or so I refer to the operations prior to measurements in a way. So this could be also quality control checks, for example. We can also use reference material to validate measurement methods. This has extensively been mentioned already. We wish to verify the results obtained. And of course, we can also use those materials for inter-laboratory comparisons. So there we might have three main goals. So to validate the method, to assign consensus values to the reference materials also, or also to test the performances of the labs, for example. So that's why they are really needed. Also, maybe another aspect is that all of this, it shows that the production of reference materials, it's kind of a very important activity to improve and maintain the measurement system. We wish the certified properties to be a good estimate of the true value. So, but we also wish those RMs, CRMs to be as close as possible to real samples. So that could be useful then to validate, as I said, the use of single methods and so on. So another aspect is that the involvement of national metrology institutes could, in the production and so on, could really help provide metrological traceability, or for some time help lower uncertainties as well. So the thing is, how we can see the thing is that, okay, we start with the best, let's say, as small as possible uncertainties, but with the complexification of the matrix or the interferences, also from other elements we wish to measure, then we'll increase those uncertainties. And at some point, we are trying to limit this effect. So, but still, we should be aware that each step, as we are going towards increasing complexity, will also increase the uncertainty. And okay, this has been really well summed up by Robert earlier. We wish to advance, well, we wish to walk towards the goal quite slowly, because we wish to put in place a kind of a hierarchy between procedures of increasing complexity, or also materials of increasing complexity, going to real samples in the end. And all of this, we should also, so I would like to cite also Jackie this morning, who recalled that what is important also not to lose the sight is to check what's the purpose, because we wish something that is fit for our purpose, and not always, we shouldn't be seeking for, no, I shouldn't put this way, but we should see the benefits of seeking too far, because we know that the resources to produce those materials are limited. So we have to be realistic. So I don't want to speak, and it's not the aim of this session that I speak too long. So I tried to sum up some of the discussions we've had yesterday. Some aspects were also again raised just earlier. Yeah, I was going to say this morning, but okay, so earlier. And so what is clear is that okay, people need reference materials or certified reference material to validate the method in mass specs. We wish also to control for the mass bias, yeah, isotope fractionation. It seems that from the radioactivity side, for uranium, plutonium especially, there are materials available, even though I heard that okay, it was mentioned that it would be needed to improve the half-life of U42, of Pu42, sorry. But mainly we lack of such reference material, and we also lack of spikes. So the aim is to certify jointly for assay and isotopic ratios. So from my notes, I think that it seems that one of the limitations also is that we might not have enough available enriched isotopes. So maybe that's okay. We will have to see how to focus on this. What was mentioned also yesterday was to maybe to be proactive to provide such isotopes. So one of the way would be to involve to produce those isotopes, and it could be beneficial also for the neutron measurement community. So that's also what happened during the Samarium 151. But of course, we see some limitations, especially as we want to provide those materials for larger community. Then we have to think about it. It was also mentioned in one of Ben's tutorial. Well, we have to see through the handling of radioactivity in mass spec labs, the nuclearization, use of glove boxes, how you handle your waste and so on. We also see that we have strong need for hyphenated techniques to monitor the separations that are needed to improve the uncertainties. And sometimes we fall into this kind of loop because we need also MS or radiometric techniques for some methods to measure half-lives. So that's also a limitation. Yeah, I've already been speaking for too long. So the idea is to have those slides to continue the discussion we've had, because to me it seems that all these aspects they are really linked. So that's why we are kind of repeating. So the idea would be also we tried to identify the needs. We try to identify some priorities, because we are all aware that developing such materials is very labor intense. It was also mentioned yesterday. So how there's this problem of the funding of all these activities, which NMI can be more involved, which NMIs, of course. Also, I was wondering about the role of the European Commission through the JRC, because okay, IRMM was providing or is providing lots of reference material as well. There are providers also from the USA, so I think that it can be beneficial to share those resources to address the priorities that we should not select, but we should identify. So this morning, again, yeah, some thorium standards it was mentioned by Richard. I'm hoping I'm not wrong. We mentioned these cesium spec yesterday, maybe some other rare earth materials. Do you see other elements? It's true that we'll have also the opinion of the stakeholders community tomorrow. So maybe this will help. I think I do not wish to go further here because, yeah, the next slide will be kind of an example or a link, which should be quite awful because, yeah, we can do this. Yeah, voilà. Yeah, I don't want to present this, just, okay, I can kind of slide to, after this discussion, I'd like to slide towards the direct presentation. So, yeah, no, sorry. So you're already there. You're still there. Sorry.
No, that's okay, Valérie. Thank you very much. Could you please stop sharing for a moment?
Yes.
I can share something.
Yeah, of course. Stop sharing. So that should be from there. I know yes.
Look for something red. There you go. Excellent. I think it would be useful to remind, especially the non-radionuclide metrology community, what the classification of services in radionuclide metrology are. You can find this list, of course, on the BIPM website under CCRI. But as you can see, laboratories throughout the CCRI Section 2 do measurement not only in gas, liquid, solids, and aerosols, but in a variety of reference materials. Water, and that really means aqueous-based, soils and sediments, flora, so plant, fauna, so animal-derived materials, building materials, which is relatively new. This is post-Chernobyl. We've added that as one of the possible media that are measured in the CCRI Section 2 community. So if you were to go to the KCDB looking for CMCs of radionuclides in reference material, you can find these various laboratories have these reference materials available. Now, whether they are available to be sold or borrowed or given is a different question, but I just want to assure our colleagues out of CCQM that we in CCRI, we do measurements and we have materials that have been well characterized and can be used in mass spec application. So with that, you will have this is from the presentation I gave yesterday morning, so you will have that available to you. Valérie, you don't have to write it down. You can have this whenever you need it. So with that, I will hand the microphone back to Valérie to lead the discussion, bearing in mind that we do have Dirk's presentation in about 11 minutes. So if you avoid talking about the Euromet project, we can discuss it at the next session.
Yeah. Oh, maybe there's something.
So I have here from Robert, the question is regarding CRMs. Do your CRMs need to meet ISO 17034 requirements in CCRI? No, they don't have to, because even we do not declare CMCs of the reference material. We declare the CMC of the measurement of a radionuclide in the reference material. But in order to do that, we have the reference materials. Some laboratories probably do follow 17034, but this is not a requirement, as we do not have declared CMCs of reference materials.
Okay, I wasn't aware of the subtleties. Okay.
Yes, it's very nuanced.
Which is not, yeah, okay, thanks.
Yeah, it is nuanced.
Okay.
Right, so what you can find are reference materials of various sorts with the radionuclides inside having very precise metrological measurement. But I don't think any have rhenium. So that is one comment. Oh, here we have, yes. Lynn has a comment. Is there a plutonium-239, plutonium-240 ratio standard available? I know there is one for plutonium-239 and plutonium-243. And I would have to ask Richard and or Jackie if they are aware. Perhaps someone from one of the other labs. Unfortunately, we don't have NPL here for this side.
Well, if you mean for activity, that's a different thing. But for isotopic composition, the U.S., I think CEA through Satama and JRC GEO all have isotopic composition for 239, 240.
Yeah. Yes, the IRMM 083 or something like this. But yeah, there's something, and for plutonium.
Lynn corrects plutonium-242, I presume, rather than 243, maybe.
Yes.
In any case, Jackie follows up with, and I'm squinting. You can't see me, but I'm squinting because I've looked at the screen for too long. I can see potentially characterizing the natural matrix material on a mass basis. Maybe this is a low-hanging fruit to follow up on. So that's one comment, and another comment comes from Janine. No, I can't read it. So Janine, maybe you can read it. My eyes are going blurry. Can you?
Lisa, I can read it. There is a New Brunswick Laboratory CRM 128, and this is certified for 239-242 ratio.
Very good, thank you.
Yes, the NBL program office is also in the process of recertifying CRM 136, 137, and 138, and those are the full suite of the plutonium isotopics. I don't know whether that will include 238 plutonium, but it'll be 239, 240, 241, and 242.
So I think this all is suggesting that there are reference materials out there.
Yes.
So, yeah.
Yes, you're right. For those, there are some which is, yeah, then, or maybe they need to be more widely known, but
publicized, perhaps. Yes, which is one of the goals for this workshop, was to make people aware that these things do exist. So, and Lynn notes that users measure 239, 240 plutonium for source term identification. And so he has very specific request for the ratio. Anyway, so other questions? Hands? Hmm.
I have, this is Jackie, somewhat of a peripherally related thought. So it seems like that one of the challenges is maybe knowing what reference materials are even available. I guess particularly for, folks who are doing rad measurements by mass spec, is it worthwhile having like a database or, that's got all that information in it for all the CRMs or SRMs and RMs that are available?
Well,
all the NMIs have their own, catalogs, but, I'm thinking more of a
repository of all
yeah.
that information.
I think there
Want
was...
to take that job on?
Yeah, that's it. Okay, it's been just mentioned. There's the COMA database from the BAM. I don't know if it's extensively, if everything is updated, but there's this. There's also the GeoRem database, I think. So
GeoRem is somewhat limited, though. I don't know if it's going to contain all that kind of thing.
Yeah.
And it's more for the geology folks.
I would say,
Yeah, I suspect most laboratory-based catalogs will be their catalog, not everybody's catalog. So I'm sure NBL has a catalog of, what they have. NIST, you look in the SRM catalog, and you can find our reference materials characterized for radioactivity. So Zoltan has his hand up.
So apart from just simply cataloging existing reference materials, it will be also quite interesting, and some of the existing reference material databasing efforts are doing that, to collect data, community understanding about reference materials, because there is data out on matrix reference materials, or on the NIST calibrator series, on isotopics and many other parameters, which are important to this community. And if we could consolidate that information in some kind of databasing effort, I think that could be of great contribution to this community.
Zoltan's exactly correct. I mean, GeoRem does that all the time. Like, people will be measuring isotopics on material that were not meant for that. So we're going there all the time, right? To go, oh, somebody's probably measured this.
Yeah, that could be also an improvement. So, okay, yeah.
And this effort would also be working, towards, identifying the holes, the gaps, both on the calibrator side and on the matrix reference material side for, method development and validation applications. Yeah.
Yes, you're right.
Robert, I see your hand up.
I just wanted to, a word of warning. I have the privilege of running two databases. One's obviously the KCDB contributing to that one, but also running a specific one for in vitro diagnostics. And I need to forewarn you the amount of work that's required to maintain any quality control database. So if something already exists, I would certainly say try and make use of it, but because establishing yourself is a lot of work.
Yes, that's why I voluntold Jackie that maybe she wants to do it. So maybe
she's aware.
I don't know. I have to ask my boss, Mike.
But maybe one approach, and we've done this for other things, is rather than our community, and I say that in general terms, developing a database. What is needed is a single site with links to all the different databases that already exist and are being updated. For example, the BIPM, and I'm not volunteering you to do this, but I can say as an example, the BIPM could host a page where they simply have a list of the different URLs to the different catalogs of reference materials out there that have radionuclides characterized in the reference material. That's just one possible suggestion, not that I'm asking the BIPM to do anything about it, but the risk of an institution, the NIST or the LNHB or the BTB or the NPL, to host such a conglomeration of resources is that not everyone will think to look to NIST, to the NPL, to the PTB. Everyone knows to look to the BIPM. So this might be something to think about going forward. Other comments, questions?
This is Lynn again.
Yes,
I have
Lynn.
2 questions regarding to the either the certified reference material or reference material. As a user, I have 2 observations over the years. First one is when I use the certified reference material, most of the time, the sample size I'm going to use for my measurement is totally unmatched with the real sample I normally analyze. I give you an example. If I analyze plutonium in food, I have to use a 250-gram food to start with. But there is no reference material give me that quantity to give me the equivalent matrix challenge I'm expecting. So usually I have a reference material, I weigh a few grams the most. So you can see the difference now, right? As a chemist, you handle a few gram samples in versus to 50-gram samples. That's a whole different story. So that's one thing I observed. The second one I observed is we talk about the natural matrix standard versus the spiked reference material. Because when you talk about the sample preparation issues, right, spiked samples is very easily leachable. And you can fool the analyst to say, oh, you recovered all the radionuclides with your procedure. But when they move on to the natural matrix standards, and the whole thing is off, right? And because they didn't fully dissolve the samples, always on the lower side. Another problem is if you go with the natural matrix standard, the option for the radionuclides and the level of the radionuclide concentration is very limited. It's driven by the nitro process, right? But the beauty of the spike side, you can put any radionuclides you're interested in and at any levels. So these 2 kinds of reference material as a user, so when I use it, I hope the NIM metrology camp have put some considerations in there and then say, okay, how are we going to produce the fit purpose reference material for the end users? Thank you.
So Lynn, I can tell you that Joe responded to your comment saying that NVL CRMs 136 and 137 are in the 239-240 plutonium ratio range that you are looking for. And as Richard mentioned, it is these are planned to be recertified. So I take your point about having exactly a mimic of what you're looking for, but part of the role of traceability is you can go from one sample to another sample through that measurement chain. I see, Jackie, your hand is up, and I know that Valérie wanted to respond to your questions, but I just want to say that my observation of 30 plus years of looking at this is that most laboratories, analytical or metrology laboratories, are using these reference materials not as a surrogate for their actual sample, but rather to calibrate the tool they are going to use to look at their sample. So that's something to maybe consider. So Valérie first to respond, and then Jackie.
No, I agree with the comments of problems, but I think that we should follow Robert what Robert mentioned about the increasing complexity, and of course, a synthetic reference material will have its drawbacks. But okay, if that's all that we have, then that's still a good start, and we can improve the confidence we have in the measurements through those small, maybe 2 small steps, but still. So as you mentioned, Liza, the traceability chain is built also this way. So I think we shouldn't discard one way of producing reference materials, as this can still be useful to the communities. And I will stop there because, okay, the time is running out.
Because it would be impossible to produce a reference material for each specific application.
Yeah, exactly.
I mean, really. Jackie. You're muted, Jackie, if you're talking.
Sorry, I thought I hit it. One of the things that Lynn brought up that's really important to recognize if we went down the path of creating CRMs that certified are both on a mass basis as well as activity basis, you know, the communities do typically use very different sample sizes, and that becomes a challenge for homogeneity of developing CRMs. So, you know, to develop a reference material that is going to address both of those communities is going to take a lot more effort and coordination and thought about how to go about doing that. It was a good point that Lynn brought up. So
yes, it's definitely a research project for sure. So I think we're at time for this discussion, although it's been an excellent discussion. Thank you very much, Valérie, for taking it all on, because Ben couldn't join us. But
thanks very much thanks very much to all the contributors, mainly.
Yeah, thank you. Robert, do you have something to add?
Yeah, I think the sample size issue is really quite an important pragmatic one. I remember discussing with colleagues at IEA on some of their sample sizes compared to some of ours. And whereas ours can fit nicely into very small vials, you know, they had truckloads of material rolling up. So it's it can be quite a different depending what level you're looking at. So I think that's something that has to be clear because practically it's quite different.
Yeah, well, homogeneity is fundamentally that in itself is a whole research project, because you can't do sampling from a larger sample size if you're not certain about your homogeneity. So how to test that and everything is.
But what sort of sample size would you be looking for? How many grams of sample would you be looking for?
Are you asking Lynn?
Yeah, I'm sort of asking the screen
In general?
generally. Yeah.
Yeah, so Lynn was.
I think, Robert, oh, this is Jackie again. Sorry, I think it depends on your application, particularly for the end user. I mean, if you're doing like nuclear forensic stuff, they seem to be like 10 grams. And then,
okay,
you know,
that's reasonable. Yeah, okay.
Because they're doing counting techniques and but you know, counting techniques, they typically seem to be using larger sample sizes. When mass spec, you know, we're definitely a lot smaller.
Yeah. Okay.
Milligram quantities. So, I mean, that's where I'm like, you know, to really put a value for activity and mass on one reference material, it's really gonna have to be thought out very carefully.
Yeah, 10 grams is fine for forensics, but in decommissioning, you're looking at half a ton. So, yeah. I mean, you can, it's quite application specific.
So if I might add, there is also the issue on the other end for really small samples, the surface type or single particle type measurement that's represent a whole other set of requirements on homogeneity and you know and associated, you know, standard issues. So it's not just the large quantities which are required for radiation based measurement, but also these surface techniques which, you know, work on micrograms of samples. Yeah,
definitely
require calibration.
Right, and if you're working from a living source material the way Lynn does with foods, you also have to think about all the background metabolism that has gone on. So different organs will have different accumulations of things, and